Alright, in this video we're going to be looking at the gold section of the Rainbow Review. So in this first question we're asked to graph the parent function of the absolute value of x, and then this other graph that's going to be a translation of that graph. So let's start with the absolute value of x. So that's just, remember, going to have our vertex at 0, 0. And remember, basically it is two lines with a slope of, well, this first one has a slope of 1 going up and to the right. It's a little off, that's off a little bit, but that's okay. And this one's going to be a straight line going up and to the left. And so that's how you get your absolute value function. So now the first thing I look at is this graph, the fact that, or this other function, the fact that this is x minus 2 means it's going to go to the right 2 units. And this plus 1 means it's going to go up 1 unit. So the vertex is no longer going to be at 0, 0. It's going to go to the right 2 and up 1. Now, before I draw my v, because if I did that, that would be wrong. Because this negative means that the graph is going to flip over the x-axis. So instead of pointing upwards, it's going to be pointing downwards. So now I'm going to have my v being flipped upside down. So that's all you have to do for that first one. For the next one, we're going to be looking at a parabola this time. For this, the graph is a little bit trickier, but we understand some basic concepts. We know that the parent function is going to start at 0, 0. Now remember, we're squaring whatever x is. So if I take and put 1 in for x, 1 squared would be 1. If I put 2 in for x, 2 squared would be 4. If I put 3 in for x, 3 squared would be 9. And we can reflect those points, and 9, by the way, didn't fit, so I didn't put it down. But we can reflect those points over the y-axis. All right, so that the y-axis right now acts as our line of symmetry. So now I can connect those to make my parabola. Looks something like that. All right, so now we're going to move this to the left 3 units and down 4 units. So the vertex, we're going to move to the left 3 and down 4. So this is where my vertex is going to be. Now remember that this point here means that's 1 unit to the right and 1 unit up from our vertex. There's no stretching or shrinking or compressing or anything like that going on. All we've simply done is we've moved this graph. So that point is going to go to the right 1 and up 1 as well. This one, we're going to the right 2 and up 4 from our vertex. So from my vertex, I'm going to go to the right 2, up 4. 1, 2, 3, 4 to get that other point. And then remember, we had a point that we couldn't graph from the vertex. If I went to the right 3, 3 squared would be 9. So if I go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 is right here. So if I put my imaginary line here, this is my line of symmetry, I can reflect those points over that line of symmetry. So now I can connect these to get a more accurate parabola there. So that's how you can do a parabola. Okay, so let's look at the back of that page. This one, without using a graph, it says describe the transformations of x squared that are applied to the graph of the function g of x. So here we have 2 times x, that quantity being squared, minus 4. Now the minus 4 is easy. That just means it's going to move down 4 units. But this 2, remember, whatever happens with the x, we do whatever happens directly with the x, we essentially want to remember that we're going to do the opposite. And so if we had up above, if we had x plus 2, that means that we would move to the left 2. Here we have 2 times x. So this is going to be a compression. We're not stretching it horizontally. It's going to be compressed horizontally by a scale factor of 1/2. And the way that you get that, remember, this means that a is 2. Remember, when we're dealing with our a value as far as what's being multiplied by x, we take the reciprocal of it. So the reciprocal of 2 would be 1/2. So it's going to be pressed horizontally by a factor of 1/2. And we could say that it's translated down 4 units. All right, so it's like the next one. So the next one, this time again, our a value is 3/4. So if we take the reciprocal of that, we get 4/3. Now 4/3 is bigger than 1. So that means that we're dealing with a stretch here. So we can say it's stretched horizontally. And then we're not going up or down at all. But we have that negative out in front. So that negative means it's going to be flipped over the x-axis. That's how you could describe that in words. Let's look at number 4. Number 4 says, without graphing, where would the vertex be for the function the absolute value of x minus 4 plus 1. So if we think about this logically, the x minus 4 means that it's going to move to the right 4 units, and the plus 1 means it's going to go up 1 unit. So if that's the case, our vertex is going to be at, is going to be at 4, since it's moved to the right 4, and it's going to go up 1. So the vertex is going to be at negative 4, 1. All right, looking at the next one, it says for the parent function, f of x equals x squared, what would be the equation for the function that has a vertex at negative 2, 7? So it's not talking about it being flipped at all either. It's not being compressed or stretched at all. So we're just going to do a translation of moving it to the left 2 and up 7. So if that's the case, our equation would be x, if we're going to move to the left 2, it's going to be plus 2 quantity squared. If we move it up 7, it would be plus 7. So that would be our equation that would have a vertex at negative 2, 7. And number 6, similar question. This time it's for y equals x, or f of x equals x squared again. What would be the equation for the function that has been flipped over the x-axis and has a horizontal stretch of a factor of 4? All right, so if we flip it, we're going to have a negative out in front. Okay, so now it's going to be stretched by a factor of 4. So that means that we want to take the reciprocal of 4 and get 1/4. So we'd have 1/4 x squared, or if you said x over 4 quantity squared, that would be fine too. Because remember what we have here is this means that a is 1/4. Whoops. A is 1/4. And so the impact that a has on the back on the graph is we would take the reciprocal of 1/4, which would be 4/1. So it'd be stretched by a factor of 4, which is what we wanted. So that's how you can write that one out as an equation. And lastly, they give us these two graphs. We want to come up with the equations for the two graphs. So these are based on the absolute value, or the parent function, is going to be the absolute value of y. So y equals absolute value of x. That's the parent function. Okay, so the parent function would have had a vertex at 0, 0. We can see here that that vertex has been moved to the left 4 and up 3. So we would say that we would have x plus 4 and then plus 3. So we see the vertex has been moved to the left 4 and up 3, so it'll be x plus 4 and the absolute value, and then plus 3. But if you notice, it's also been flipped over the x-axis, so we'd have to have a minus in front of there. And lastly, for this one, it's been moved to the right 1, so we'd have x minus 1. And then it's been moved down 6 units, so then we'd have minus 6. It hasn't been flipped or anything, so that would be your answer for that last one there for 7b. So that's how you do this gold section of the review. So hopefully that answers the questions that you may have had.